question. It says, draw a picture of the following orbitals, the 1s, 2s, and 3s on the same set of axes. Let's start there, and then we'll go through the other ones. And this was something that we went over, at least to the best of my knowledge, in the lecture outline, but it's important enough to do again and talk about as we do it. So let's see. We'll start with A. So we're going to draw it with the nucleus at the center of the axes, and 1s, 2s, and 3s are going to be a series of circles, at least to the best of your ability. And as you go from the nucleus out, you're going to have n equals 1, n equals 2, n equals 3. And so it's sort of the same picture that we had before. You can draw them as long as they're in this order, meaning the bigger values of n are farther from the nucleus, your drawing is fine. The next level of complication would be, well, it's not even worth the next level of complication. So just draw them. So as you get larger values of n, you get farther from the nucleus. And as we've seen from, and then let's talk about the S aspect of this. S sublevels, or let's just go singular. NS sublevel has one orbital that is spherical. So these circles really represent spheres, and that's what we need to know. Now for part B, it says the 2s and the 2px on the same set of axes. So I'm going to try and draw, well, a new set of axes, and then approximately for the n equals 2, the same size as above. And then I'm going to draw a sphere. Yeah, well, we'll try. I did say I was going to try and draw a sphere. So this is n equals 2. And the 2s is going to be a sphere. Like so. And we'll zoom in a little bit here so we can see it a little better. Now, the 2p, so in the 2p sublevel, or a 2p sublevel, has 3 orbitals. And you can see them for part C, 2px, 2py, and 2pz. And we're only going to draw 2px here. And when you draw a p orbital, you're going to not touch the nucleus. You're going to get as close as possible to the nucleus without touching it. And you're going to draw basically 2 balloons. And if you draw the 2 balloons, or what I also call the 2 dumbbells, along the x-axis, which I'm calling this the x-axis, it is a 2px. And the important part of this drawing is that the outside edge of the 2px and the outside edge of the 2s, which is what this sphere is, right? And that's a little confusing, I get it. N equals 2 and the 2s, they are basically the same thing. As far as size goes, certainly. So the important thing about this drawing is that the 2px and 2s orbitals end at the same distance from the nucleus. Okay. Another relatively important thing is that the 2p orbital doesn't touch the nucleus either. Any questions about part B? All right, then let's move on to part C. Part C says, well, let's read the question. Draw the 2p, 2px, 2py, and 2pz on the same set of axes. So I've already drawn my 2px, and so I'll just draw that approximately the same, not touching the nucleus. And these two, what are called lobes, two parts of the 2px, are one orbital. So 2px has two parts or two lobes that make up one orbital. Okay. And then we are going to, on the y-axis, draw the exact same shape. Attempt to anyway. And this is going to be 2py. And then the super tricky part is drawing 2pz, because the 2pz should come, there we go, out of the page at us. And how we're going to do that is we're going to draw the z-axis as a thick line. There's the z-axis as it comes out of the page at us, and as a dashed line as it goes back into the page. So this z-axis is perpendicular to the page. That's very hard to draw on the page though. And then we're going to draw the exact same shape along the z-axis. So it's going to look very thick when it comes out of the page at us, and then it's going to be dashed as it goes back behind the page. It's a little complicated drawing, but what we're showing is that, okay, in part B, the P's fit within the S sublevel. They both end at the same place. And then there are three different p orbitals along each of the axes, the x-axis, the y-axis, and the z-axis. And what we can think of is that the n equals 2 principal energy level is big enough, because it's bigger than the n equals 1, is big enough to accommodate 8 electrons. Or let's see, is big enough to accommodate 8 electrons in 4 orbitals, and these are what the orbitals look like. The n equals 1 is much smaller. It's not big enough to have p orbitals. N equals 2 is big enough to have p orbitals. N equals 3 is big enough to have s, p, and d. So as they get bigger, as n gets bigger, there are more and more ways to put electrons into that principal energy level. So let me back up a little bit, show you all of the answers here for this part. I think, there we go. Any questions about this? My only question is, why is my coffee almost empty? Okay, so Rensei, I see your question. I saw the review homework sheet for exam 2. Is all that going to be on the exam? Answer, no. Right? I'm not going to tell you exactly the questions that are going to be on the exam. I have given you more. And I know it's like, well, if the exam review just says know everything, how useful is it? I don't think it says know everything, but it does say know most of it. Um, so, uh, but no, it's not all going to be on there. If you know that stuff, though, you will be in good shape. And I did leave some stuff off. Point well taken, though.